Welcome to Get Your FRQ On. This question is from 2022. It's question 2, and it is calculator active. In the question stem, we have two functions, f and g. We have the graph of both f and g on a limited window, and we are given that the graphs of f and g intersect at x equals -2 and x equals b, where b is some positive number. In part A of the question, we are asked to find the area of the region enclosed by the graphs of f and g. In order to do this, we're going to set up an integral, but at this point we don't know the bounds of integration because we only know that the graphs intersect at -2 and some positive number b. We need to find b. All right, so this is a calculator active question, so we can use our calculator to determine when the graph of f and g intersect. So we need to know when natural log of x plus 3 is going to equal x to the 4th plus 2x cubed. And this implies that x is either -2 or 0.7819751. And because our graphing calculator is using the graph to find the point of intersection here, when the graphing calculator does something from the graph, it's typically less precise. So rather than round this value to 3 decimal places, we're only going to round and once we get to a final answer for this area. So we're going to use this value 0.7819751, and that will be our value of b, and we're going to use all the decimal places that we know. So the area of this region can be found using the definite integral from -2 to this value b of f of x minus g of x dx. And again, because this is a calculator active question, we can let our calculator do this calculus for us. And it turns out that that area is about 3.604. In part B, we define a new function h of x, which is the vertical distance between f and g. And we are asked if this function h of x is increasing or decreasing when x is -1/2. Well, since h of x is just the vertical distance between f and g, h of x is literally just f of x minus g of x. And if we want a derivative for h of x, we can just do f prime of x minus g prime of x. We can evaluate h prime of x at -1/2 by evaluating f prime at -1/2 and g prime at -1/2. And again, because this is a calculator active question, we could use our calculator to determine those values, and it turns out that h prime of -1/2 is -0.600, which notably is less than 0. So we conclude that because h prime at -1/2 is negative, this function h of x is decreasing at x equals -1/2. In part C, we're given that this region is the base of a solid and that cross sections taken perpendicular to the x-axis are squares, and then we are asked to compute the volume of that solid. Now, since cross sections are being taken perpendicular to the x-axis, we're going to integrate with respect to x. All right, so that volume is going to be found using the integral from -2 to b of f of x minus g of x squared dx. And again, it's a calculator active question, so we have this integral we need to evaluate. We're going to let our calculator do that work, and the volume would be 5.340. In part D of this question, we have a vertical line moving left to right at a rate of 7 units per second. And we are asked to calculate dA dt when x is -1/2. That is, the rate at which the cross-section area is changing when x is -1/2. So this is a really tricky question unless you recognize it for what it is. This is just an application of the chain rule, right? We have our area function, that's just f of x minus g of x squared. Remember, cross sections are squares, and the length of one side of that square is just f of x minus g of x. So because this is an application of the chain rule, it's essentially a related rates question, we can set it up as an application of the chain rule, and we don't have to get too complicated with it either. All right? We know that the location of this vertical line is a function of time. All right? And our big area function, capital A of x, is a function of x. And I want dA dt, which is just dA dx times dx dt. Well, we know that dx dt is 7. That's given to us in the question stem for this question. And then we just have to figure out dA dx at x equals -1/2. Okay, well, we have our f function, we have our g function. We can define a of x to be f of x minus g of x squared. And because this is a calculator active question, we can do all of that on our calculator and then just use our calculator to evaluate dA dx when x is -1/2. Take that result, multiply by 7, and we get that dA dt is -9.272 square units per second when x is -1/2.